So in 11.5, we're doing pretty much the same thing as we just did in 11.4, but instead of working with circumference and arc length, we're going to work with area and sector. Okay, so a term here that's important is the sector of a circle. All right, it's just basically a pie piece of a circle. So if you take a circle and you cut it up with a certain angle, this is going to be called a sector. All right, so we're going to find the area of those sectors, and it's the same exact concept as how we did the arc length. Okay, so we know the area of a circle is pi r squared. R is the radius. The area of the sector is just sector is just going to be theta over 360, right? So a fraction of that, which you're going to find from that central angle, just like we did with the arc length, times pi r squared, which is the area. Okay, so a simple example, it's just like this. Let's say we got 60 degrees, and the radius is 6. So you'd plug in 6 for r, plug in the angle for theta, and you can find the area of your sector. Another way to think of this is 1/6 of the whole area. So you could just find the area of the whole circle divided by 1/6, or I guess multiplied by 1/6, or divide by 6, and that'll give you the area of your sector. So let's jump right into the example. So to begin here, we're going to work backwards again and find the diameter of a circle with given the area. So we need the area equation, pi r squared. Right, now diameter is not in there, but that's okay. Let's just find the radius and then multiply it by 2. That's the easiest way to go about that. Okay, so we've got A is 120 pi. It tells us what the area is, equals pi r squared. Now because there's a pi on both sides, you can just get rid of them, cancel each other out when you divide them off. So we just have to take the square root of both sides, and r equals square root of 120. Well, square root of 120 we know we can reduce. All right, the way we're going to reduce that is by dividing by all of our perfect squares until we find one that works. And the biggest one that you can use is just 4. So you can pull out the 2 and you're left with 30. Okay, so that's the radius, but we need the diameter, so we need to multiply that by 2. And the diameter is going to be 4 root 30. That's it. Now, number 2, we're going to find the radius of a circle with area 48. The reason I did this one is just because there's no pi in it. It's the same concept, but without a pi in it, it makes it a little bit more complicated. Okay, so because there's no pi in there, you just have to divide by pi. So we've got r squared equals 48 over pi. Right, then take the square root of both sides, and you're obviously not going to be able to get a good answer there. We don't know the square root of pi very well. Okay, so what you can do is just give me a decimal answer in that case. So we can just take the square root of 48 divided by pi, which is 3.9. And that's the radius. Okay, number 3, now we'll start finding the area of sectors. We're going to find the area of a shaded region. This one is very easy. They give us, this angle is 135. They give us the radius is 14, so we just have to plug it into our equation. And we get area of a sector equals 135 over 360 times pi times 14 squared. Now, I want pi in your answer as much as possible, okay? So we're going to take the 14 squared and then multiply that by 135 over 360, and you get 73.5, okay? So when you're at 73.5, I just want you to write 73.5 pi, okay? Leave the pi on the end. That's perfect. All right, now number 4, we're going to find the area of the unshaded region. Okay, so that's going to be a little bit more difficult for us because they give us the angle for the shaded region. So we need to find the angle of the unshaded region. Well, luckily we know that all the way around the circle is 360, and we're going to subtract off the 50 to get the angle to be 310. So the area of our sector then becomes pretty easy. 310 over 360 times pi times 2, which is our radius, squared. So we could do 4 times 310 divided by 360, and you get 3.444. All right, so if you have something like that, a repeating decimal, I'd like you to write that as a fraction. Okay, so just hit math right underneath alpha, enter, enter, and it converts it to a fraction for you. So the area of the sector is going to be 31 over 9 pi, which you could just throw the pi on the numerator. All right, and lastly, number 5, we're going to find the area of the shaded region again. This one's a challenging one because we've got this little messed up triangle that we got to take off. Okay, so the best way to do this is to find the area of the whole sector and then subtract off the area of this triangle. All right, so that's why I said this one's a little bit more complicated. Alright, so we need to first start by finding the area equals the area of the sector minus the area of the triangle. Okay, so let's start with finding the area of the sector. The area of the sector is pretty easy because they give us everything we need. So, area of the sector equals theta, which is 120 over 360, times pi times 24 squared. We could just type right in our calculator, 24 squared times 120 divided by 360, and it gives us 192. So we have 192 pi. All right, now the area of the triangle, we need base times height. Well, the thing that is good about this is, if you look over here, right, this 120, when you cut it, right, we know this is 24. Right, when you cut that 120, or that 120 degrees in half to create a little right triangle here, we've got a 30, 60, 90 triangle with our 60 there. So we could solve the 30, 60, 90 triangle. Right, if the 24 is the hypotenuse, that means the short side here is going to be 12, and the long side is 12 root 3. Okay, so now we have the height is 12. The height of our triangle is 12 because this is the same as that. And the base of our triangle is going to be 12 root 3 times 2 because that's halfway across. So the area of the triangle is 1/2 times base, which is 24 root 3, times height, which is 12. Okay, so we can multiply that out, and we're going to get 144 root 3. So the final area of our shaded region is what it just needs to be those two subtracted from each other. So the area equals 192 pi minus 144 root 3. Okay, so that's the exact answer. If I asked for a rounded answer, you could type in your calculator 192 pi minus 144 root 3, and you're going to get 353.8. That's the final answer.